Hi, I'm Thomas. Welcome back. Our topic is integration. This is integration using partial fractions, example 2. Our problem reads, find the integral of 9x squared minus 3x plus 2 over 9x squared minus 4 with respect to x. Working with our algorithm, step 1, identify a function type. We have a rational, we have a function in the numerator, function in the denominator. There's no clear way that we can use substitution to work with this integral. So since we're dealing with a rational function, we're going to consider using partial fractions as our procedure. Before moving forward with partial fractions, we need to check whether we have a proper fraction. I'll evaluate the degree of the numerator, the highest exponent of the x. The degree is 2 over the degree of the denominator. The highest exponent of the x is again 2. This means we have an improper fraction. We want a proper fraction, a fraction in which the degree of the numerator is less than that of the denominator. In order to do that, we're going to divide the numerator by the denominator. So I'll set up my division as 9x squared minus 3x plus 2 divided by 9x squared. Notice that my next term is a degree of 0 for x. I'm going to add in a middle term, which is 0x minus 4. And now our divisor includes terms for all degrees of x. X to the power of 2, x to the power of 1, x to the power of 0. Looking at the first term of the dividend and the first term of the divisor, they're both 9x squared. Dividing 9x squared by 9x squared results in a quotient of 1. So I'll put a 1, which is x to the power of 0, over the x to the power of 0 term in the dividend. And now multiplying each of the terms in the divisor. 1 times 9x squared is 9x squared. 1 times 0x is 0x. 1 times negative 4 is minus 4. We'll subtract each of these terms. Note it's important to distribute the minus sign. 9x squared minus 9x squared is 0. Negative 3x minus 0x is minus 3x. Plus 2 minus minus 4 is plus 6. So in addition to the 1, we now also have a plus negative 3x plus 6 over 9x squared minus 4. I'm going to now rewrite the integral as our quotient. The integral of 1 plus negative 3x plus 6 divided by 9x squared minus 4 with respect to x. I can factor the denominator of the second term, so I will have the integral of 1 plus negative 3x plus 6 over 3x plus 2 times 3x minus 2 with respect to x. And now I'll be able to work with the partial fractions method. I have the fraction negative 3x plus 6 over 3x plus 2 times 3x minus 2. I'm going to set this equal to my partial fractions setup. Since my two factors are both linear, and both of the factors in the denominator, the degree of x is 1. I'll set up my first fraction as a over the first linear factor, 3x plus 2. My second fraction will be b over 3x minus 2. Let's be more accurate. This is not an equality. This is an identity. The left side is an identity with the right side. Now I'll multiply both sides of the identity by the denominator of the left side of the identity. On the left, we'll have remaining negative 3x plus 6 is an identity with a times 3x minus 2 plus b times 3x plus 2. From here, if we let x equal negative 2 over 3, then a equals negative 2. And if we let x equal positive 2 over 3, then b equals 1. And now I'll rewrite my integral. The integral of 1 plus the first fraction, a over 3x plus 2. A is negative 2, so we have minus 2 over 3x plus 2, plus b over 3x minus 2. b is 1, thus plus 1 over 3x minus 2 with respect to x. Now I'm going to manipulate the second and the third term so that I can integrate two log terms. 1 minus. In the second term, the denominator 3x plus 2 has a derivative of 3. So I want a manipulation that puts a 3 in the numerator. To get to 3 over 3x plus 2, we multiply by 2 over 3. With the third term, 1 over 3x minus 2, looking at the denominator, 3x minus 2 has a derivative also of 3. To get to 3 over 3x minus 2, we'll multiply by 1 over 3, all with respect to x. Now, after quite a bit of algebra, we're ready for step 2, apply integration rule. So our integral, the first term is 1. 1 integrates to x. The second term, minus 2/3 of the integral of 3 over 3x plus 2, integrates to the natural log of the absolute value of 3x plus 2. And the third term, 1/3 times the natural log of 3x minus 2. Adding our constant of integration, plus c. We've completed steps 2 and step 3. Now step 4, simplify. First step of my simplification, I'm going to do a reorder and one manipulation. So equals x, I'll not change or move that term. I now want the positive natural log term to come first. When I have an addition of a natural log term and a subtraction of a natural log term, then I can set up a quotient of the two arguments as one log term. So I'm going to write the next term as plus 1 over 3 times the natural log of 3x minus 2 minus, what comes next is 2/3 times the natural log of the absolute value of 3x plus 2, but I'm going to change this to minus 1/3. Factoring out 1/3 from 2/3 leaves 2. 1/3 times 2 is 2/3. Now where is that times 2 going? It's going to become an exponent. 1/3 times the natural log of the absolute value of 3x plus 2 to the power of 2. So I factored the coefficient 2/3 into 1/3 and 2. I've kept 1/3 as a coefficient to match the coefficient of the other log term, and I've moved the 2 to the exponent of the argument of the log term. And our fourth term plus c. And finally, equals x plus 1/3 times the natural log. And notice now both natural log terms have a multiple of 1/3. We're adding the first term, subtracting the second term, so I'm going to set up a quotient. The absolute value of the added term, 3x minus 2, over the subtracted term, 3x plus 2 to the power of 2, plus c. And this is the integral of the given expression. We've completed our requirements. This completes integration using partial fractions, example 2.